So so this is the week 10. So right now we learn. So we learn a linear line. How to find a linear line and two linear line relationship. They are crossing. They possibly overlapping. They possibly perpendicular to each other or parallel to each other. Yep. So up to now, we do some a little bit extended. There is one or two linear line. They are crossing. They possibly perpendicular to each other. They have one common point, right? If they are overlap, they have infinity kinds of common point. If they are parallel to each other, they have no common point, right? All these, so they have this one have overlap. They have infinity solutions, and their slope is exactly the same. Their y-intercept is exactly the same. If they are perpendicular, if they are parallel to each other, they have no solutions. So we didn't need to find the answers for them, right? So when they are crossing or they are perpendicular to each other, they have one common point. We can use the graphing, just like this one. We can find out their graphing methods. And right now we talked about homework part. We talked about just like say they can use the substitution methods. So we finish this part. So we move on. Find the two special lines. Yes, the two special lines, we talked about that one already, right? One is horizontal line. When there are two lines, when they are horizontal line, when one line is horizontal line, if the other line is parallel to this horizontal line, it means another horizontal line, right? If another line was perpendicular to this one, so they have to be vertical line, right? Just keep this in mind. So vertical line, horizontal line, they don't have very good, they don't have one of them vertical line, like the slope is infinity. The other one, horizontal line, the slope is 0. So they didn't matter the first slope times second slope equal -1 kinds of rule to judge if they are perpendicular to each other, right? They cannot use this kinds of judgment. So they have to these kinds of methods we have to judge by graphing, right? By graphing horizontal line, vertical line. Their relationship to judge have to be used the graphing methods. So if one told you say that's a vertical line, and another line actually perpendicular to this vertical line, so they have to be horizontal line, right? So just like this one. So this one is we actually right now we already talk before the homework review part, and we just talk this one more time. And how to get the two linear line cross point, graphing, substitution. So last week we talked this part. So today we move on. Use the addition elimination methods. All right. So let's go see some examples. Let's see this one. All right. Find the common point of two linear lines by substitution. Substitution method actually last method we learned last one. So let's use the substitution methods we're familiar with very well, right? Okay, so substitution methods, firstly, we need to find x equals something or y equals something first, right? Just like use one of the variable expressed by the other variable. So we can find out in these two linear lines, this expression, they only have y. So we can use this one, say y equal 3x plus 6, right? So y equal one of the variable expressed by the other variable. So y equal this part. So in the second line, the y can be replaced by here, substitute by this one, right? So we can get is, so this expression actually replaced by this y substitute by this one, right? 3x plus 6, so equal -14. This is substitution methods, right? So we can simplify, first distribute inside, right? So you got a negative 2x equal 4, right? X equal negative 2. So we got a y replaced by here, y equals 0, right? Y equals 0. So check it. You can check it. Check it here. Check it here. Put this data into both expression. They should be both make sense. All right. So substitution is like this way. So how we do addition, elimination methods. Right now we use the addition or elimination. What this means? We use these methods, use the addition or elimination methods, try to make one of the variable disappear. What it means? So it means something like here. So let me rewrite this part one more time. This system. This is one of the linear line, right? This is second linear line. All right. So what do we need to do here? Make one of the variable. This is two variable, right? One is x, one is y. So we make one of the variable disappear. How we make it disappear? Let's see this one. Let's see this one. So both sides, you can see this part. Here is negative 3y. Here is positive 3y. If times 3 of this one, times 3 of this one, both sides times 3, both sides times 3, right? So this one will became what? This expression will become what? Became negative 9x plus 3y equal 18. So this expression and this expression is the same, right? It's exactly the same, both sides times 3. So in this situation, this is the left part of the first expression with the left one. This is right one, right? This expression we say L2, R2, right? L2 equal R2. So if the left part plus together, they still equal right part plus together, right? Left part, right part. So left part plus together equal means what? So left one here is 3x minus 3y. What about this one? So here is became negative 9x plus 3y. What about right part? Right part is here is negative 14, here is 18, right? You can see this one, left one plus together, right part plus together. So what objective here? Objective here is we make this y disappear. Negative 3y plus 3y, they are gone. So you can see this expression, only one variable, right? So became negative 2x equal 4. So x equal negative 2. See, they are the same, right? Useless. And this is called addition, left part addition, right part also addition, right? Addition methods. So make one of the variable gone, disappeared, eliminated, disappeared, just it's gone. So y, what a y equals to? So right now we can put this back to here, any one of them to get y, right? So you can say positive 7 times negative 2 minus 3y equal negative 14. So here negative 14, so y, negative 3y got 0, so y got 0. Y got 0. So we got the same answers, negative 2, 0. Same as this one, right? Right. So this is called addition elimination methods. Actually, the objective is make one of the variable gone, disappear. All right. Okay. So this is the one way we make y disappear. We also can make x disappear. All right. So how to make x disappear? Let me rewrite this part one more time. So here is 7x minus 3y equal negative 14. So here, this time make y disappear, right? Right now we want to make x disappear. All right, so what I have to do here? So I want to make x disappear. So I need to make x result the two terms, this term and this term, they plus together became 0. So what I need to do? So let me times 3 for this part. So here became 21x minus 9x. So here became 21x minus 9y equal negative 42. All right. In the second one, in the second term, I times 7, both sides times 7. All right, so times 7, that became negative 21x, right, plus 7y equals 63. Right, all right, so you can see what kind of transformation here. Here became 21 minus 3 minus negative y equal negative 42. And the other one is both sides times 7. So change into like this. What objective here? So this is left 1, right 1, left 2, right 2, right? So left part plus together. So left part plus together. What it became into? They change into what? So this part is plus together. Left 1 plus right 1, left 1 plus left 2. So x will disappear, right? What about y part? Became negative 2y, right? What about right part? Right part plus together as well. So became negative 21, right? Is it correct? Look, something I somewhere do wrong, right? Oh no. 6 times 7, how can I get a 63? Here is 42, right? I'm wrong here. At 6 times 9 is 63. 6 times 7 is 42. So here is 0. I'm sorry for that one, for the wrong. I hopefully anyone can point out my wrong part if I'm do something wrong. So here is 42. 6 times 7 is 42. Right now I write 43. I definitely see somewhere wrong. I say, what's going on here? So right part x equals 0, right? All right. So you got a y equals 0. So y equals 0. Put anything back here. Something like put it in the first expression. So you got the x equal what? So 7x equal negative 14, x equal negative 2. So also got the result should be negative 2, 0. So this one actually is make y disappeared. This part is x disappeared. Do proper transform. Both sides times the same number. The equation doesn't change, right? Except this, when we time the same number, this number cannot be 0, right? So that's the point. So it means left 1 equal right 1. Left 2 equal right 2. These two equations. Both sides, if the sign times the same number, doesn't change. This m, of course, cannot equal 0. You can, both sides can times n, right? Can do this kind of proper transform. The objective is make one of the variable, one of the x or y disappear. So when they ml1 plus nl2, they still equals, right? They still equal to each other. Keep this in mind. Or maybe say minus, top minus bottom, top minus bottom. They still equal to each other, to equal. So left part minus the right part minus, they still equal each other. That's the formula. But the point is make one of the variable disappeared. So you can get the solutions quickly. Okay. All right. So before I make it clear, let me save one of the picture here. All right. So let's see some more examples. All right. See this one. If based on this one, definitely we can use the substitution method. It's easily, right? Substitution methods. All right, if we use the substitution methods, what we do? X replace substitute by this one, right? X equals something. So in the second expression, second equation, we can use the X equals something, substitute here. So you can got 2y plus 5 minus 1 equal to, I don't think this is a good example, firstly. So you can see here. So you can got y plus half 5 minus y equals 2. Oh no, you can see y also disappeared. Here became like this. Did this make sense? Definitely not make sense, right? So it means what? It means something wrong in front. We didn't judge there if these two lines is parallel each other or overlap to each other, or they have crossing. So here's something wrong. Let's go back, check here what's going on here. All right, so here is actually do proper transform. It means y equal what? If y equal half x minus 2, right? What about this one? Y equals what? X minus 5 divided 2. Did you see this one? What's going on happening? So the slope of this one is half. The slope for this second one also is half. So first slope, second slope, they are the same. When they are the same, it means at least these two is parallel or overlap, right? So since their y-intercept part is different, so it means these two lines is parallel to each other, means there are no solutions. There are no common point. Of course, there are no solutions. So I'm sorry, I should say sorry. I didn't give quite a good example here for the addition elimination methods. Let's go a little bit further. Go to the next one. All right. So let's see this one. Find their common point based on addition elimination methods. So what we need to do here. Okay, so we see this one. First one. What do we do? First, we try to make y disappear because it looks like y is easy to make it disappear, right? So only thing is needed here is negative y, here is 2y. So with first equation, we just time 2 first. Time 2. All right, time 2, both sides time 2. So it's changed into what? 6x minus 2y equal 8. The second one is x plus 2y equal 8. So first equation, second equation, right? So left 1 plus left 2 equal right 1 plus right 2, right? Okay, so here became 7x, left part plus left part. This y was gone, disappeared, right? So x equals 16 over 7. We quickly can get solution x, and we y equal what? So you can see y equal 4 minus 3x minus 4, right? Right? Y equal 3x minus 4. 3 times x minus 4. Here equal what? 48 minus 4, 28. 40. Right? So we got 16 over 7. Right? The first methods will make y disappear. So you can get these solutions. All right, so we can see second method. We make x disappear. Let me erase this part. How to make x disappear? Make x disappear. So what we need to do here is time 3, okay? The second term, time 3. Because time 3 here became 3x minus y equal 4. The second one is 3x plus 6y equal 24. First equation, second equation, right? So here is left 1 equal right 1, left 2 equal right 2. Let's do it this way. Left 1 minus left 2. So equals y1 minus y2, right? Okay, so left 1 minus left 2. So here became, so 3x minus 3x became 0, right? Let me write down like this way. A little bit more detail. So left 1 minus left 2, right? Y1 minus Y2. Minus Y2. So we got x is disappear. Objective is make x gone. X gone. So here becomes negative 7y equal negative 20. So y equal 20 over 7. Right? So close here. They are the same. Right? So you can put it back to find the x as well. Definitely. Should be this one. Should be also equals here. You can do by yourself right now. All right. The first method is make x disappear first. Make y disappear first. And second method is make x disappear. Right? So both works. Finally, a common point. Finally, a common point. Okay. Let's see second examples. Two more examples. Actually, a lot of examples in my list here, but fine. Let's do this one quickly. All right. So see this one. Okay. So we do proper transform this one first. Proper transform, because a transform can make it easy to well understand. Sometimes have fraction not easy to read, right? All right, so do proper transform. Both sides divide times 2. Times 2. So it's okay, negative 2x minus 2y equal 5. It's both sides times 4. All right, times 4. Negative 2x plus y equal 0. Right, correct? Both sides times 4. Times 4. Both sides times 2. This both sides times 4. All right, can you guys do this? So you get this one. All right, so let's say 1, 2. We say first one, we make x disappear. So 1 minus 2. 1 minus 2 means left 1 minus left 2 equal right 1 minus right 2. Right? So left top minus bottom. So here it became 2x minus y minus negative 2x plus y, right? Equal 5 minus 0. So this x was gone, right? Here became positive x. Here became what? Negative y minus y became negative 2y equal 5. So y equal 5 over 2, negative, right? All right, so x equal what? X would be easy, right? X equal what? Because y was ready, so actually easy to determine y equal half y, right? So x equal 5 over 4. So you can get this one quickly. All right, so you can do the first method here. It's make x disappear. You got a y, right? What about second methods? We can make y disappear. Y disappeared. If we make y disappear, we just left 1 plus. So 1 plus 2. The first equation plus second equation. All right. So it means left 1 plus left 2 equal right 1 plus right 2. Right. So left part is became negative 4x. What about right? It's 5. So x equal negative 5 over 4. See the same results. They match up. So you should have got a y equal negative 5 over 2 as well. All right. So we use the two methods. First method is make y disappear. This one make x, make x disappear, make y disappear. Right? Both works. The result should be exactly the same. Both are least conclude result. Right? So addition elimination methods, that's not too much trick, right? Not too much trick. Not too much methods. Just make this one of the variable gone, so you can find the solution easily. All right, let's see the last example. All right, let's see this one. This one. All right, so it's proper transform first. I think I let the fraction part go, make it easy to read. So both sides times 2 first. This one both sides times 4. So you can quickly get what? Negative 4x plus 3y equal 10. Second one, negative 2x minus y, right, equal 2, right? All right, so first we make x disappear, all right? Sounds good. So we times 2 more here, times 2 more here. So here became negative 4, 2, 4. Both sides times 2, right? So we can change this one. So equation 1, equation 2, first minus second. First top minus bottom, top minus bottom. So you can got 5y equals 6. Right? So y equals 6 over 5. Easy? All right. So x got what? So you need to put it back to get 1 of the x, right? X equal, you can see from this part. So since y is ready, so 10 minus 3 times this one, right? And also divide negative 4. So you can get x equal what? Here is negative 20, top is 50 minus 18, 32, right? Both sides divide 4. So it's 8, negative 8 over 5. So you got an x out of there, right? All right. So we make x disappear. You guys can try how to make a y disappear. Sounds good? Sounds good. Anyone have question of this part? So addition, elimination, actually, no big change, no big trick trick to get the result out. All right. All right, so since we learned the addition elimination methods, the objective, we try to find the common point. What's the common point? Right? All right, so we move on a little bit further. When we do the, earlier we learned the functions, right? Fx, actually y equal mx plus b can be transformed into m. Y can be transformed fx equal mx plus b, right? This kind of equation. Actually, this, when we're graphing, this kind of always is a linear line. So fx change. So when today we will do a little bit further, when we do graphing this kind of linear line, they have an absolute value inside. How we do that? Absolute value inside this kinds of expression. How we do that? Okay, let's see some examples. Quick example. So if you say y equal x, can you guys graph in this one? You can graph for this one. X 0, y, right? 1, 2, 3, 4. 1, 2, 3, 4. All right. So when you graphing this one, how you graphing? You can quickly is they pass 0, 0, right? They pass 0, 0. They pass 1, 1. They pass 2, 2, right? So when you graphing, you can just say, oh, okay, I can graph this one quickly, like this. So it's this one is y equal x, right? No problem. Everyone can do this one, right? By the way. So, okay. So what I to do is this one. They have y equal absolute x. What it means? So when x is a positive number, when x is greater or equal than 0, y equal x. When x less than 0, this line became y equal negative x, right? So it means x, this part, y equal x, they keep the same. When x less than 0, y equal negative x. Y equal negative x is like this way. Y equal negative x. What's the difference between initial and to here? Like this one was spanned up, right? make it bend up here. This is the center line, bend up. So just flip over up. Make they all above this y equal negative x. Just like this is y equal x in this part. And then bend up like here. So all the result, all the y value actually greater or equal than 0. Is it correct? Right? Right. So this is very typical and quick way of understanding. When the absolute value in this kind of expression, how you graphing. So actually graph line, it should be like this, right? So it should be 1. So one line is right here. One line is right here. Just make it a little bit quick better like this. So this one is not right. This part is not. This part we don't need it, right? So when you're graphing y equal absolute x, you're graphing like this way. Right? So it's not a straight line anymore. So they are actually made of 2 parts. One part is when they are less than 0 is y equal negative x. When they greater or equal than 0, they will be this. Made of 2 parts. Okay. All right. So let's see graphing this one first. When we graph this one, let's graphing like this one. Y equal x plus 1. How to graph this one? So they passed 0, 1, right? Pass negative 1, 0. So when we're graphing, we easily can graphing out there is like this, right? Okay, all right. So absolute means make all the data when the y less than 0 became top part. Actually is this one. You can see this part. When they x negative 1, this part is okay, right? This part is okay. This part is okay. But this part is left part less than negative 1 part is y less than 0. They need to bend up. They need to bend up here. So actually line is this part. So we have to erase this part. We don't need this part, right? No, this one. So the graphing is like this. Actually, this one is means what? Means x greater equal than negative 1. This y equal x plus 1, right? When they x less than negative 1, so this inside will begin 0. So y equal negative x like this. Right? It's negative 1. So actually y equal negative x negative 1. You understand? So that you do not have this pink line. Let me graph this. Right? So when you graphing the absolute, graphing have any function with a subroot, you can see all the results above y equals 0. All right. So I will send these 3 as a homework to you guys. Graphing it. Sounds good. That's all for today. Sorry, still 5 minutes over time. So I wish you guys have a very wonderful Halloween. Get a lot of candies. Happy Halloween, everyone. See you next week.
Thank you.
Bye.
Bye.
Bye. Thank you.
Yeah, very welcome. See you. Happy Halloween. See you next week.